Okay, hello everyone, guys. How are you? Good morning, a very good morning to one and all. तो guys, I hope आप सभी ने रिवीजन किया होगा. आई होप आप सभी ने जितने भी हमने होमवर्क डिस्कस किया था आप सभी ने रिवीजन किया होगा, होमवर्क किया होगा. तो गाइज टुडे आई विल बी स्टार्टिंग विद द मशीन लर्निंग कोर्स एंड द टॉपिक वुड बी लॉजिस्टिक रिग्रेशन. बट उससे पहले एक बार जो भी हमने थ्योरेटिकल कॉन्सेप्ट्स पढ़े, आई एम डैम श्योर अगर वो चीज अगर हम एक बार जुपिटर फाइल पे भी देख लें एंड ईच एंड एवरीथिंग अगर जो भी हमने पढ़ा, इफ दैट थिंग इज रिप्रेजेंटेड हियर, नो आई थिंक एक प्रैक्टिकल और थ्योरेटिकल को आप कहीं ना कहीं लिंक कर पाओगे, है ना. तो दैट इज वाई आई हैव एक्चुअली आई मीन ओपन दिस रिग्रेशन फाइल जो कि मैंने किया था अपने टाइम पे व्हेन आई वाज डूइंग दिस कोर्स, नो. तो देयर आई एक्चुअली have made this regression file and I want कि आप भी एक बार जरूर इस फाइल को देखें and all those practical thing, I mean all those metrics, no, जो कि हमने किया था. I think we can discuss it once and then we shall move forward. Okay, correct. ओके चलिए. तो सी मल्टीपल लीनियर रिग्रेशन का एक ये हाउसिंग केस स्टडी है दैट आई डिड. ओके, एंड यहाँ पे फर्स्टली द डेटा, मैं आपको डेटा सेट दिखा दूँ. कुछ डेटा इस तरीके का है ना. तो डेटा सेट में हियर वी हैव टू प्रेडिक्ट प्राइस. ओके, इन द डेटा सेट वी हैव टू प्रेडिक्ट प्राइस. और जो इंडिपेंडेंट वेरिएबल्स हैं वो है एरिया, बेडरूम, बाथरूम, स्टोरी, मेन रूम, गेस्ट रूम, बेसमेंट, हॉट वाटर हीटिंग, एयर कंडीशनिंग, पार्किंग, प्रेफ एरिया एंड फर्निशिंग स्टेटस. तो बेस्ड ऑन दीज इंडिपेंडेंट वेरिएबल्स आई हैव टू गेस और आई हैव टू प्रेडिक्ट द प्राइस. ठीक है, तो ये एक एक्चुअली में रियल टाइम केस स्टडी है जहां पर जिसको आप यूज करके यू कैन एक्चुअली प्रेडिक्ट द प्राइस. तो मैं जरूर आपको ये शेयर करना चाहूंगा ये चीज. तो आई वुड शेयर दी हाउसिंग डेटा डॉट CSV फाइल मेरे पास है. ओके ओके चलिए. नाउ दीज आर सर्टेन इंपॉर्टेंट स्टेप्स जो कि हम बहुत ज़्यादा डिस्कस नहीं करेंगे डिटेल में. शेप से क्या होता है, वी जस्ट गेट टू नो हाउ मेनी कॉलम्स एंड हाउ मेनी रोज आर देयर. इन्फो से यू वुड गेट टू नो हाउ मेनी नॉर्मल एंट्रीज, व्हाट आर द डेटा टाइप ऑफ दिस कॉलम्स, राइट. एंड whenever you write describe, so there you would get to know mean, standard deviation, everything. Now comes the visualization part. तो यहाँ पे दो लाइब्रेरीज इंपॉर्टेंट होती है, एक तो होती है मैटप्लॉटलिब और सेकेंड वन इज सीबॉर्न. ठीक है, अच्छा. अब विजुअलाइज आप कर सकते हैं, यू कैन एक्चुअली गेट टू नो व्हाट इज द बिहेवियर ऑफ ईच कॉलम. ओके, तो इसके लिए आपको थोड़ा सा स्टैटिस्टिकल कॉन्सेप्ट्स क्लियर होने चाहिए. व्हाट इज अ गॉसियन डिस्ट्रीब्यूशन, बर्नौली डिस्ट्रीब्यूशन क्या होता है, कि रफली आपको डिस्ट्रीब्यूशन कैसा लग रहा है ना. तो ऑल दीज थिंग्स यू कैन चेक द आउटलायर्स एंड नंबर ऑफ थिंग्स. ठीक है, यू कैन चेक. अच्छा, अब यहाँ पर कैटेगोरिकल वेरिएबल्स को हाउ टू डील विद कैटेगोरिकल वेरिएबल्स, सी दिस इज अ पार्ट ऑफ डेटा साइंस. तो मैं बहुत ज्यादा डिटेल में नहीं जाऊंगा, ये डेटा साइंस का पार्ट है. मैं सीधा आ जाता हूं यहाँ पर, क्योंकि यहाँ पर एनकोडिंग करनी होती है. ओके गाइस, तो वी हैव टू डू एनकोडिंग, राइट, वी हैव टू कन्वर्ट दिस. तो मैं बहुत ज्यादा डिटेल में नहीं जाऊंगा, आई वुड डायरेक्टली कम टू दी मॉडल बिल्डिंग पार्ट. और उससे पहले मैं आपको एक चीज दिखा दूं. आई गेस आप शायद इसको गेस कर सकते हैं. आई थिंक आपको ये पता होगा. व्हाट इज दिस मैप कॉल्ड, हमने डिस्कस भी किया था. इस मैप को हम क्या कहते हैं, आई थिंक हमने डिस्कस किया था. दिस इज नोन एज हीट मैप. ठीक है, दिस इज अ हीट मैप. और यहां पर जो वैल्यूज लिखी हैं, फॉर एग्जाम्पल 0.35, 0.53, 0.097, व्हाट आर दीज वैल्यूज. इन वैल्यूज को गाइज हम कहते हैं, दीज वैल्यूज आर द कोरिलेशन कोएफिशिएंट्स. ओके, कोई भी मान लीजिए जैसे अब ये 0.53 है. व्हाट इज दिस 0.53, दैट इज द कोरिलेशन कोएफिशिएंट बिटवीन व्हाट, बिटवीन प्राइस एंड एरिया. तो एरिया और प्राइस के बीच में ये जो 0.53 आप देख पा रहे हैं, दिस इज व्हाट, दिस इज द कोरिलेशन कोएफिशिएंट. ओके, एरिया और 0.5 के बीच में जो आप देख पा रहे हैं, दैट इज द कोरिलेशन कोएफिशिएंट. ओके, तो गाइज कोडिंग देखो, कोडिंग गेट में नहीं पूछेंगे आपसे, दे वोंट बी आस्किंग यू लाइब्रेरीज, दे वुड बी क्वेश्चनिंग मोर ऑन दी बेसिक कॉन्सेप्ट. ठीक है, बेसिक कॉन्सेप्ट पे वो क्वेश्चन करेगा, न्यूमेरिकल आपको देगा, थ्योरेटिकल नॉलेज पे क्वेश्चन करेगा, डायरेक्टली लाइब्रेरी आपसे नहीं पूछेगा. ओके, चलिए. अब इसके बाद I would just start my discussion by building a linear model. Okay, तो अब यहाँ पर which library I have used? I have used statsmodel.api library. Okay, statsmodel.api library मैंने use किया है. And initially I have taken only a single variable, that is area. एरिया, एक सिंगल इंडिपेंडेंट वेरिएबल को एरिया को लेके आई क्रिएटेड द मॉडल, और आप देख सकते हो y hat equals to mx plus c, तो दिस इज y hat, okay, and you can see the constant, that is intercept term, and the coefficient of area, that is 0.04621. okay, अच्छा चलो, अब हमारे पास y hat equals to mx plus c, this model is with us. okay, now what we want is, we want that what should be, if I want to represent the predicted line, okay, with the scatter plot. Actually we have done this, no? So this is y hat equals to mx plus c, this we have. okay, now I want to represent that how prediction line looks like when I present that y hat equals to mx plus c on that scatter plot, okay, between dependent and independent variable. So guys, this is the scatter plot, and this red line is the y hat equals to mx plus c line. okay, that is the best fit line. Up now here you can see ki what is the r square value, okay, what is f statistics value, what is p value. I think everything we can now just see. So how we can see this, very very important. So we can just see OLS regression results. I hope you remember this OLS. What is OLS? OL is ordinary least square method. I hope you remember this word. This is ordinary least square method. So you can just calculate the r square value, that is 0.283, adjusted r square value 0.281, guys. okay, so guys, it is, I think you are able to now judge the things that we have studied in the last class, exactly that things this library is calculating for you. okay, so guys, scikit-learn library calculates for you, but what exactly is happening in the backend, that should be clear. okay, what exactly is happening in the backend, that should be clear, guys. Here this r square value, what is r square, what is the formula of r square, that you know. What is the range of r square, that exactly you know. What is adjusted r square, I would discuss this today. okay, I would discuss this today. What exactly this adjusted r square means, you exactly know. So guys, just roughly fitting the model won't fetch you anything. okay, it won't fetch you a good job, even a good score. okay, or you won't be able to clear interviews, trust me guys. okay, this is important, the coding part is important, but what is actually happening in the backend, that is also very important. okay, so that is why I just displayed this file here, and all those things which we have studied. See, everything we can't do. This f statistics, that is a statistical concept. No, I won't be discussing this. okay, log likelihood, we would be discussing this in the logistic regression. okay, so yes, AIC, BIC, these are all statistical concepts. I won't be discussing because that is not in the course. But yes, all these things are important, and most important is what is actually happening in the backend. आपने लगा तो दिया, ले तो आए भाई, बट चल क्या रहा है पीछे वो भी तो पता हो. okay, anyone can question you, भाई कोई भी आपको जो इंटरव्यू में खंगाल सकता है, कोई भी, anyone can question you in the interview, भाई what is this r square value, how to improve that r square value, what do you mean by this r square value. okay, so guys, that is why I just feel that yes, coding part is important, and equally the theoretical part, the conceptual part is also important. okay, chaliye, so now I want to improve this r square value. okay, I want to improve this r square value. So how to improve this r square value? So I would be adding certain other variables. okay, I would be adding certain other variables such as area and bathroom. Now I would just fit the model and I would see the r square value. I hope you're able to see that the r square value is gradually improving. So what does this signify? It signifies that your model's prediction capability is improving. okay, what does that signify? It signifies that your model prediction capability is improving. Acha, ab here adjusted r square is also increasing. okay, here adjusted r square was what, 0.281, and here adjusted r square is 0.4 point kitna tha, ha, 0.477. see, adjusted r square, basically it is a concept that tells us that adding the variables is actually useful or not. okay, so it tells us whether adding the variable is useful or not. So guys, I added area and in the next turn I added bathroom. So when I added the variable bathroom, whether my prediction capacity has increased or not, that would be determined by adjusted R square value. So of course, yes, the adjusted R square value has been increased. That means yes, my prediction capability has increased. Okay, now I would add one more variable, that is bedroom. Then I would check again what is R square value, what is adjusted R square value. Again, both of these values have been increased. Okay, and these are the coefficients of all these variables, right? So that means yes, adding value is actually increasing my prediction capacity. Okay, Vishal, F statistics, no, there is a formula that presently I do not remember, since that is not there in the gate, no, so I won't be touching it. Okay, so I would say if you could just search it online, no, it will be very useful, no, and easy for me also. Okay, so similarly I added now all the columns, okay, all the variables I added, right? And then I calculated the coefficients. Along with this, I calculated the R square and adjusted R square value. So you can see, guys, that R square and adjusted R square value both have been increased. Okay, so what does that means? Yes, adding the variables have actually added reliability, okay, to the model. Okay, my model has become more and more reliable, right? So this is what adjusted R square value means. Okay, so yeah. Okay, then we have VIF, that is variation inflation factor, that is defined as 1 upon 1 minus Ri square. That is nothing to do with the gate. Okay, this is just for your knowledge. So variance inflation factor, actually it gives us how many variables to keep, okay, in the model. So it is a general practice that the value of VIF greater than 5, I mean the variables for which the value of VIF is greater than 5, those models are generally avoided. Those models we avoid. Okay, so that is general a practice. Okay, generally that is a practice, no, that we do. Okay, so the value greater than 5 are eliminated, right? So I would be just eliminating what all, I would be eliminating the bedroom, main road. Okay, so this is how we do it. Okay, so I won't be touching this. I won't be touching this more. Okay, so this is how I fit the model, right? Okay, and this is the prediction results, and these are the prediction results, right? So this is the residual analysis. I hope you are able to see this. This is the residual analysis part. Okay, and does it follow the normal distribution? Yes. So see, we saw this assumption, no, we have considered this assumption that it shall follow the residual it shall follow the normal distribution. Okay, it shall follow a normal distribution. So basically it follows the residual analysis is displayed here, and I hope you can see that it is following a normal distribution, right? So this is how you have to actually see. Okay, this is how you have to actually see that whenever you are given with the question, this is how you have to actually analyze the data. Okay, and you have to approach it. So guys, it is important that to code with the data set, but it is more important that what exactly the things are there in the backend, that also should be there in your mind. Okay, then only you will be able to actually code more and more better and understand things better. Okay, chaliye. And now, yeah, this is how I can make the prediction. Okay, so using the test data I can make the prediction. Okay, so this is how I can make the prediction, and this is evaluation. Okay, this is evaluation. So in the evaluation I can actually calculate MAE, MSC value, okay, everything. And this is how a prediction model looks like, right? This is how a prediction model looks like. This is the prediction model. Okay guys, this is the prediction model. This is how this prediction model looks like. Price, that is equals to 0.236 into area plus 0.202 into bathroom. So that this is what, this is the prediction model. Okay, this is how a multiple linear regression model looks like. Guys, I would be really happy to tell you, when I was doing my PhD, no, so if you just type my name on Google, no, if you just type my name on Google, you would find my number of papers, no, you can find number of papers where actually I have made certain prediction models. So if you just see my this paper, no, So in this paper, I just published this paper in 2022, okay, in the CIRP journal. So there also I have actually modeled, I have also created a multiple linear regression model. Okay, so if you can just search my name on Google, so you would find number of papers, right? And this is one of the model. This is one of the papers where I actually try to minimize the dimensional tolerance, and that in polyjet additive manufacturing. I hope you must have heard this word 3D printing. Okay, so in 3D printing, I did my PhD. My topic was 3D printing, and there actually I created certain ANN predictive modeling. What is this ANN? This is artificial neural network. Okay, this is artificial neural network. So there I just created this models. Okay, so if you just search my Google Scholar profile, no, so here also I have done certain more papers such as multi-material fabrication and compressive strength optimization. So here also I actually this paper I published in Springer in SCI journal. So here also I created certain models, right? And yeah, so I mean this is very good. I mean this machine learning part, no, that is really very good. So I would say that if at all you are interested, no, so it has lot of things to give to you. Okay, this has a lot of things to give to you. Okay, so yeah, so just I wanted to motivate you. If at all you are I mean interested, definitely you can just pursue these things, and machine learning would help you a lot. Okay, this would help you a lot. Okay, chaliye, so now let us switch back to our topic. Okay, now let us switch back to our topic. Yeah, now let us switch back to our topic. So today we have to start with logistic regression part. Okay, so today we have to start with logistic regression part. So please write the heading logistic regression. Okay. Okay, chaliye. So now we'll start with the new topic, that is logistic regression. Okay, so please write the heading logistic regression. I'll start with the basic. Yes, yes, Newsbuster, I'll just check it. I'll check it. Okay, just give me 1 hour. No, let me complete this topic. I'll check it for sure. For M2, I'll just check it. Done. I'll just check it. So logistic regression. So I'll start with the basic theory of logistic regression. Okay, chaliye. So it is a supervised learning approach. So you write with me, it is a supervised learning approach. Okay, it is a supervised learning approach. Okay, and a supervised learning approach means that we should have a labeled data set. Okay, so what this supervised learning approach means, it should have a labeled data set. Okay, it should have a labeled data set. Okay, it is majorly used for binary classification. Okay, this approach is majorly used. Okay, this approach is majorly used. This approach is majorly used for binary classification. Okay, this approach is majorly used for binary classifications. Okay, this approach is majorly used for binary classification. So binary classification means that wherever we have yes no class, okay, wherever we have yes no class, 1 0 class, so majorly it is used for the binary classification class prediction. Okay, and sigmoid function is used to calculate the probability of the class. Okay, so here sigmoid function, here sigmoid function is used. Okay, sigmoid function is used, sigmoid function is used to calculate the probability of the classes, to calculate the probability of the class. I hope you are able to get what exactly this class means. Okay, now for example, if I just draw a random data set, no? For example, if I am drawing a random data set, so there I have certain input variables. Okay, there I have certain input variables x1, x2, x3, x4, x5, and here I have this target variable. So in the target variable, if I have only two categories, yes and no, or 1 or 0, or -1 or 1, so if these categories actually falls here, no, if these categories are actually here, so that is known as okay, so this is known as binary class. Okay, this is known as binary class. That means in the target variable only two categories are there, yes no, 1 0, -1 1. Matlab if such scenario arises, no, that is known as binary class data set. Okay, that is known as binary class data set, right? So here the predicted output is not a continuous function. Okay, so here the predicted output जो है, that is not a continuous function. Okay, here the predicted output is not a continuous function. So predicted output would be what? Is not a continuous function, it would be a categorical function. Okay, rather it is a categorical function. Rather it is a categorical function. Okay, rather it is a categorical function. That is why it is a classification. Okay, that is why it is a classification algorithm. Okay, that is why we'll call it as a classification algorithm. It is not a regression, it is a classification algorithm. Okay, that is why it is a classification algorithm. Okay, certain important points I would write, so I expect you to write. Okay, so yes, we would discuss sigmoid function, everything we'll discuss. Okay, just don't worry. So now certain important points I would write, that is important for the examination point of view. Okay, so it is a discriminative model. Okay, so I would just write note. Okay, just note certain important points. Firstly, it is a discriminative model. Logistic regression is a discriminative model. Okay, so please write these certain important points. It is a discriminative model. Then secondly, I would write output is non-linear. Okay, secondly I would write output is non-linear. Okay, output is non-linear, right? Third, I would write that it is a probabilistic algorithm. Okay, it is a probabilistic algorithm. Okay, I'll discuss each and every point. Okay, you just write it first. Okay, it is a probabilistic algorithm. I'll discuss each and every point. Okay, I'll discuss each and every point. So it is a probabilistic algorithm. Acha, the decision boundary is linear. Okay, the decision boundary is linear. I'll discuss what exactly decision boundary is. Decision boundary is linear. Okay, then fifth point would be it is used for binary classification. Okay, used for binary classification problems. Used for binary classification problems. Okay, acha, here log loss is cross entropy loss. Cost function is log loss. Okay, what is the cost function? Cost function is the cross entropy loss. Okay, in logistic regression, what is the cost function? That is the cross entropy loss, और I would say log loss. इसको हम log loss भी बोलते हैं. Okay, तो cost function is cross entropy loss or log loss. Okay, so that is what the cost function is. Okay, so you just write the important points. Now let us discuss how logistic regression was modeled. Okay, now let us discuss how logistic regression was modeled. PDF notes are already available. There is a link. Okay, you can find each and every PDF there. I've uploaded it. Please guys, you can, if you could help in the comment section, those who have found it. Okay, so PDF is already available there. Okay, yeah. Okay, so please complete it. I'll just wait for a minute guys, then we have to do number of questions. Okay, chaliye, complete it. Okay, now let us see. Now let us see how logistic regression was developed and why logistic regression was developed. Okay, so I would just start with a data set. Okay, I would just start with the data set. The data set is that I would be making the independent variable as sugar. Okay, sugar is my independent variable and diabetes is the dependent variable. Okay, sugar is the independent variable and diabetes is the dependent variable. Okay, right. Up now, for example, when sugar is 180, then diabetes is no. Okay, then we don't have diabetes. When sugar is 190, we don't have diabetes. When sugar is 200, then also the person is not diagnosed with diabetes. Now when sugar is 260, diabetes is yes. When sugar is 270, diabetes is yes. And when sugar is 280, then again he has diabetes. So this is the data set that is given. Okay, this is the data set that is given. So here the sugar is the independent variable. Okay, here the sugar is the independent variable and the diabetes is what? Diabetes is the dependent variable. Okay, diabetes is the dependent variable. Now I would try to just locate all these points. I would try to locate all the points here. Okay, acha, no, I am considering as 0 and yes, I am considering as 1. Right, so this is 0 and 1. Okay, so on the x-axis I have taken sugar. Okay, on the x-axis I have taken sugar and on the y-axis I have taken diabetes. Right, now I'll start with 180 when sugar is 180, when sugar is 190, when sugar is 200. Okay, then when sugar is 260, here 270 and here 280. Okay, here sugar is 280. So I have 3 points here. Okay, I have 3 points here and I have 3 points here. Okay, I have 3 points here. Right, so 3 points on the x-axis and 3 points on the y-axis. Okay guys, this is the basics of logistic regression. Why actually it was developed, let us see. Okay, please carefully, let us focus this. Okay, chaliye, now if I want to make a linear regression model, okay, initially if I want to make a linear regression model, this would be the straight line, that would actually be joining these average of these three and average of these three. This is how we can make a straight line. I hope you are getting this. Bhai, if you want to make a linear regression model, how you can make a linear regression model? You can just take average of 180, 190, 200 and just join a straight line with the average of 260 to 270, 280. So this could be one of the straight line with the equation y hat equals to mx plus c. Okay, y hat equals to mx plus c. Okay, अच्छा, अब यहां पर guys, the problem that comes with the logistic regression is that, for example, if you add, instead of these 3 points, no, if you add 30 points, okay, if you just modify these 3 points to 30 points, if you add 27 points here and 27 points here, for example, instead of these 6 points, I have a total of 60 points. Okay, so here, in this case, the diabetes for 0.5, the diabetes for 0.5 is shown at a certain sugar level. Okay, the diabetes where the diabetes is 0.5. Okay, at this point when the diabetes is 0.5, for example, that is shown at a sugar level of 2, for example, 230. Okay, but this point would change if I add 27 more points here and 27 more points here. Okay, so that means after adding certain points here and here, the major problem with linear regression is that if I add more points, I mean, instead of these 3 no, if I add 30 no and 30 yes, the orientation of this straight line would change. So initially, मतलब जो हमको 230 पे दिखा रहा था कि diabetes is 0.5, अब वो क्या करेगा, हो सकता है 235 पे दिखाए. Okay, initially when at 230 it was showing that diabetes is 0.5. So it would show now at 235 or 240 if I add certain number of points here. Okay, so that means on the addition of points, the shape of the line would change. Okay, on the addition of the points, what would happen? The shape of the line would change. That is the major problem. That means the line would become dynamic. The linear regression model would become dynamic. Okay, so that is why it was experimented that if I use a sigmoid function, okay, it was experimented that instead of using a straight line, what I would do, I would use a sigmoid function. That means what I'll do is I would just write that z equals to mx plus c. Okay, so this y hat I've replaced by z is equals to mx plus c, and I would be writing the linear combination of these parameters. Okay, linear combination of these parameters. So what is z? Yeah, I would just write z. What is z? Z is m into sugar. Okay, m into sugar plus c. Okay, this is z. Okay, this is z. What is z? M into sugar plus c. Now what I would be doing is I would be just replacing this linear combination of parameters into a sigmoid function. So I can say that if I replace the linear combination of these parameters, okay, into a sigmoid function, so that can give me an easy bifurcation to just determine whether a person has diabetes or a person doesn't have diabetes. Okay, so this is the major reason that why this regression line has been converted from a linear line to a non-linear output, where this is the sigmoid function. Okay, this is the sigmoid function. This is known as sigmoid function. So ab now what I would do, I would actually replace. I would actually replace with z. Okay, instead of z, what I would write? I would write minus of m into sugar plus c. So this is the crux of logistic regression, guys. This is the crux of logistic regression. That is why this sigmoid function has been used. Okay, नहीं तो होगा क्या, बार बार ये line ऐसे होती रहेगी. Okay, whenever you just added or subtract certain data points, what would happen? This line would be converted. Okay, this line would change. So bhai, why to change this line? Why to be so dynamic? So what we did is we actually just created the linear parameters, and this combination of linear parameters was actually taken from here and just put here in the z. So now sigma z is basically what? It is the output. sigma z is what? It is the output that tells us whether a person has diabetes or not. Okay, whether a person has diabetes or not. Okay, so what is the range? What is the range of the sigmoid function? What is the range of the sigmoid function? So sigma z has a range between 0 to 1. Okay, sigma z has a range between 0 to 1. Okay, sigma z has a range between 0 to 1. Now in this case I can consider, matlab in this case I can just say that if sigma z ranges between 0 to 0.5, then person doesn't have diabetes. Okay, no diabetes. Okay, no diabetes, or I can say that the output is what? Output is 0 or no. Okay, output is 0 or no, that depends. Okay, and if the sigma z is between 0.5 and 1, then person has, yes, diabetes is there, or I can say output is 1. So this equal to sign can change depending upon what? Depending upon my requirement. Okay, depending upon the data set, my requirement, this equal to sign can change. Okay, so this is the concept of logistic regression, ki why this linear line is replaced by a sigmoid function to make the system more stable. Okay, to make the system more stable. Okay, so after converting this, okay, so this is what? This is the linear boundary. I would just say this is what? This is known as linear boundary. Okay, this is what? This is known as linear boundary. Now how it would change? Again I would just draw the diagram. Again, for your clarity, I would just draw the diagram that, for example, yeah, okay, for example, if this is the linear boundary, now how the graph would change? So this would be the shape of the graph. Okay, this would be the shape of the graph. Okay, this would be the shape of the graph, and this point at where the linear decision boundary cuts the logistic regression curve, this is 0.5. Okay, this is 0.5. So diabetes is equals to 0.5, where this sugar level will hit a diabetes equals to 0.5. Okay, sugar level would hit a diabetes equals to 0.5. Okay, so I would just firstly draw the sigmoid function graph. I would just firstly draw how sigmoid function graph is drawn. Okay, so this is sigmoid function graph. Okay, so at x equals to so what is the curve? Sigma z is e to the power of minus z, right? E to the power of minus z. So if you just put okay, e to the power of minus z, so where this curve would be 0, so if you just put x equals to 0.5 or z equals to 0.5, right? If you just put z equals to 0.5, it would be 0. Okay, so this is how graph would be. So this is how graph would be. Range is between 0 to 1. Okay, and this is 0.5. So at z equals to 0.5, sigma z would be 0. This is how graph is there. Okay, this is how the graph is there, S shaped. Correct, yeah, Vishal, S shaped graph is there. So this is how this sigmoid function graph is there, and this graph is actually replaced here. So in the yellow we had a linear boundary. Okay, in the yellow we had the linear boundary, and this red is the converted sigmoid function boundary. Okay, this is what? This is sigmoid curve. Okay, this is sigmoid curve boundary. Okay, the yellow one is linear boundary and the red one is sigmoid curve boundary. Okay, so this is the major crux of logistic regression. That is why the name regression is also added. Okay, that is why the name regression is also added. We don't remove the name regression because that has been converted from linear regression to logistic regression while using a sigmoid function. Okay, that is why the name regression is also there, right? Yeah. Okay, so this is the previous graph, this is the previous graph, and this graph would be changed. This graph would be changed, converted to a sigmoid function graph. Okay, this graph would be changed and converted to a sigmoid function graph. Okay, guys, so please draw this. Okay, now one more concept that I want to discuss is that is log odds. Okay, very important, log it or log odds. Okay, one more concept that I want to discuss is log odds, the concept of log odds, right? It is also very important and highly asked, right? This concept is log odds. See, now what we have is, okay, okay, yes, what what we have is that sigma x. Okay, that is what, that is the probability. Okay, sigma x, I can also say that this is the probability of calculating of what exactly x is. Okay, up now for example, if I calculate sigma of 180 sigma, okay, in the previous example, okay, in the previous example I had, I'll just draw this table again. Okay, so the table was that, yeah, the table was that we have sugar as the independent variable and kya tha ye diabetes, yeah, and diabetes as the dependent variable. Okay, so sugar kya thi 180 190 200. Okay, the sugar was, yeah, sugar was 180 190 200, then we had 260, then we had 270 and we had 280. Okay, so diabetes was no, diabetes was no, diabetes was no, diabetes was yes, it was yes and it was yes. Okay, so if you just calculate sigma 180, okay, if you just calculate sigma 180, right, and if you calculate sigma 190 and if you calculate sigma 200, all these values would range, all these values would range less than 0.5. Okay, less than equals to 0.5. Okay, all these values would range in less than equals to 0.5. Okay, the range of all these values would be less than equals to 0.5. So basically the output of these functions, for example sigma 180 sigma 190, so output of these functions are what? These are the probability. Okay, these are the probability, these values depicts what? Probability of depicting class no. Okay, so what exactly the output means? This is the output of the probability, this output means the probability of depicting the class no. Okay, and similarly if I write sigma 260, okay, sigma 270, okay, sigma 280, so this value would be what? This value would be what? This would be a value greater than 0.5. Okay, so what these value would signify? What these value would signify? This would signify the probability. Okay, this would signify the probability of depicting, class yes. So this would signify a probability of depicting class, yes. Okay, अब now if it is equals to 0.5, so that depends on the data set, that 0.5 is coming for no diabetes or 0.5 is coming for class diabetes. That depends कि 0.5, if you have taken 0.5 for class no or you have taken 0.5 for class yes, that depends. Okay, that depends on the data set and our requirement. Okay, so we won't be considering that, gate would actually specify this. Okay, no worries. चलो अब यहाँ पर the point is that what is this log odds. Okay, the point is that what is this log odds. So for calculating log odds, okay, for determining log odds, what I can write is the probability of depicting of any class is actually equals to what? 1 plus e to the power of minus x. Okay, as I've discussed earlier, the probability of depicting any class, that is what? That is equals to 1 to the power of e to the power of minus x. Okay, acha, ab here in our case what I would write? In our case I would write e to the power of minus z, where what is z? Z equals to mx plus c. Okay, we have already discussed this. Z is equals to what? mx plus c. चलो अब यहाँ पर this is what probability would look like. Probability would be what? It would be 1 plus e to the power of minus mx plus c. Okay, this is the probability. This I would write as equation 1. Okay, this I would write as equation 1. Now I would calculate the value of 1 minus p. Okay, now I would calculate the value of 1 minus p. कितना आ जाएगा? So this would be how much? 1 plus e to the power of minus mx plus c. Okay, minus 1 upon 1 plus e to the power of minus mx plus c, right? Okay, अब this would come what? This would come equals to e to the power of minus mx plus c upon 1 plus e to the power of minus mx plus c. Now what I would do is, this is equation 2. Okay, this is equation 2, that this is equation 1 and this is equation 2. Okay, now what I have to do is, I have to divide p upon 1 minus p. Okay, now what I would do is I would divide p upon 1 minus p. So what I would get? So what I would get? So 1 upon 1 plus e to the power of minus mx plus c upon e to the power of minus mx plus c upon 1 plus e to the power of minus mx plus c. So I would just cut the denominator with the denominator. Okay, so what I would be getting? I would be getting e to the power of mx plus c. Okay, I hope the things are clear. What is m here? I hope the things are clear. What is m here? Yes, Lucky, I won't be telling this again, bacha. I hope the things are very clear. What is m here? See, I started from this, no? I started from here, y hat equals to what? mx plus c. That was the initial best fit line that I got. Okay, from here only I started. That is m. फिर इस m को मैं convert करके आगे तक लाया हूँ. Lucky, I hope beta this is clear now. है ना? Done. Okay, so yes, I would be getting p upon 1 minus p equals to mx plus c, right? Acha. Now, if I take the log of this, okay, now what I'll do is I would take the log of p upon 1 minus p. Okay, what I would do is, if I take the log of p upon 1 minus p, so what I would get? I would get mx plus c. Okay, what I would get? I would get mx plus c. तो मेरे भाई मैंने जहां से स्टार्ट किया था मैं वहीं पर पहुंच गया. I hope you are able to see this. Lucky Ranjan, जहां से मेरे भाई मैंने स्टार्ट किया था, the point from where I started, I reached exactly to that point. Okay, from where I started from here, that I have a data set with me. Okay, and I want to predict this. I have a data set with me, I want to predict this. तो मेरे भाई मैंने यहीं से स्टार्ट किया था. I just started with y hat equals to mx plus c. मैंने sigmoid function को fit मारा. Okay, what I did is I just fit the sigmoid function. Okay, I started from there and I fit the sigmoid function. And after taking the log of p upon 1 minus p, I again reached to this position, mx plus c. That means this ln p upon 1 minus p is known as log odds. Okay, so that means this ln p upon 1 minus p, this is known as log odds. It is known as log odds, or we can also say it as log it. Okay, both are correct. Okay, both are correct. So it is known as log odds, or I can say this as log it. Okay, both are correct. So the benefit of calculating log odds is what? Is the range. Sigma x is between 0 to 1. Okay, the sigmoid function is between 0 to 1, right? Already we have discussed this. Now if you just calculate, acha, here what is sigma x? I'll just write, no, sigma x is what? Sigma x is sigmoid function, है ना? So what is sigma x? That is sigmoid function. Okay, this is sigmoid function. So sigma x की range कितनी है? What is the range of sigma x? That is between 0 to 1. 0 to 1. Okay, what is the range of p upon 1 minus p? This range is between 0 to infinity. Now if I calculate the log of p upon 1 minus p, what is the range of this? So range is minus infinity to infinity. So beta, this is the major advantage. Okay, this is the major advantage of actually calculating the log odds. The output range increases. जो 0 से 1 के बीच में आपको निकालना था उससे बहुत ज़्यादा range आ गई. Okay, so this is the major advantage of using log odds. Okay, this is the major advantage of using log odds. The output range increases. So that is between minus infinity to plus infinity. Okay, this is between minus infinity to plus infinity. Okay, the range is between minus infinity to plus infinity. So now I hope you are able to realize why log odds is important, because the range of sigma x was what? Between 0 to 1. Output range was very small, but while calculating log odds, firstly I'll get the decision boundary. Okay, firstly I'll reach the decision boundary, and secondly my range of output would increase a lot. So that is the main advantage of using log odds. Okay, so this is the basic funda of logistic regression. Okay, this is the basic funda of logistic regression, and number of questions are there on log odds and log it. So do not miss this lecture. Always write this on the formula sheet. Okay, so have some 3 to 4 A4 pages stapled there and just write it there. Okay, sure. And for your kind knowledge, how to calculate odds of anything, for your kind knowledge, how to calculate odds of an event. So odds of an event, for example, odds of an event P. So how to calculate odds of an event P? That would be P upon 1 minus P. Okay, from there only that has been derived, right? P upon 1 minus P. Okay, for example, the event is, yeah, so I'll just ask you, the event is chances, event is India wins against Pakistan 4 times. Okay, India wins against Pakistan 4 times. India lost against Pakistan only 1 time. So what are the odds of winning India? Okay, what are the odds of winning India? So that is favorable upon favorable upon unfavorable. Okay, favorable upon unfavorable. So what is P of win? Probability of win. Probability of win is 4 by 5. What is probability of loss? Probability of loss is 1 by 5. So if I want to calculate odds of winning India, so that is what? 4 upon 1. Okay, 4 upon 1. तो इंडिया के विनिंग के odds कितने हैं? फेवरेबल अपॉन अनफेवरेबल. ओके, तो यू शुड ऑलवेज रिमेंबर, दो इट वुड बी कवर्ड इन मैथमेटिक्स, बट देन ऑल्सो यू शुड रिमेंबर इट. ओके, तो odds of winning India is this. तो what is the event? Event is this one, no? Winning of India. ठीक है, तो what are the odds of losing India? What are the odds of losing India? Favorable upon unfavorable. Okay. Okay, but I'll wait for a minute. Please write it. Then let us proceed further. Yes, yes, sure, sure. So the right part is what? The right part is basically the range, no? That right part is basically the range of the sigmoid function, of the odds of any event and the log odds. So if you just go from the sigmoid function to the odds, the range of the output value changes. Okay, the range of the output value increases, and when you shift from odds to log odds, the range of the output value increases. So that exactly we want. So our range was between 0 to 1, but once we shifted from odds to log odds, so our range has shifted from where? Minus infinity to plus infinity. So that is the major advantage of using what? Of using logistic regression, log odds, okay, or log it. So this is the major advantage of using this. Okay, and I would just write one more important point. What is the cost function? Cost function in logistic regression. Cost function in logistic regression is log loss. Okay, is log loss. Okay, cost function in case of logistic regression is log loss. Okay, and it is also known as maximum likelihood function. So firstly I'll write here maximum likelihood function, then in the further lectures I would explain log loss. So firstly I'll write maximum likelihood function. You have to remember this. Okay, maximum likelihood function. Okay, this is the cost function in case of logistic regression, maximum likelihood function. Okay, so you have to you have to learn like this. Okay, maximum likelihood function, and after that I'll explain what exactly log loss means. Okay, so yeah, the maximum likelihood function is the cost function in case of logistic regression. We'll be doing certain questions, just don't worry. Yeah, I will be doing certain questions. Okay, loss function and cost function are bit different. Okay, Vishal, I'll explain this. Loss function, cost function are bit different. So if you calculate on an average, अगर एक average में आप लेते हो, तो that is known as your loss function. Okay, and what is cost function? For a certain point, if you calculate what exactly is the loss, so that is known as cost function. Okay, so there is bit difference, not much. Nature wise they are same, but yes, there is bit difference. Okay, chalo, no worries. Firstly let us calculate, firstly let us do certain examples. Okay, firstly let us try certain examples. Okay, so numerical part are important. So first let us do certain numerical part. Okay, chaliye. So we have this question. Consider the following model used to classify samples into two classes using logistic regression, right? Learning parameters are given, y equals to 0.4 and c equals to 0.2. Okay, y equals to 0.4 and c equals to 0.2. If p greater equal to 0.5, then assign the class label good. If p greater equal to 0.5, then assign the class label good, else assign the class label bad. What class labels are assigned to the following test samples? So these are the following test samples. What class label is assigned? So if your logic is clear for the logistic regression, yes, this is the numerical. Okay, so if your concept is clear, just tell me what are the class labels for these four samples. Okay, everyone just calculate on your own. Okay, I hope, yeah, yes, I hope now my voice is coming. Yes. I hope now my voice is coming. Correct. Okay, so now what I have done is nothing. I have done simply I used the sigmoid function formula. Okay, what I've done is I have used this sigmoid function formula, and using this sigmoid function formula I just entered the learning parameters. Okay, I just entered the learning parameters 0.4 and 0.2. Okay, I just entered the learning parameters 0.4 and 0.2. Now after this what is, yeah, after this what the case is, that 0.4 into x. Now what is x? X is 1.2, then x is 0.4, x is 2.4, and x is 0.2. So I would be just entering the value of x here. Okay, I would be just entering the value of x here. So what is sigma 1.2? Okay, what is sigma 1.2? Okay, so you would be getting all the values. Okay, you would be getting all the values greater than 0.5. Okay, you would be getting all the values greater than 0.5. Okay, you would be getting correct all the values greater than 0.5. Okay, so first one would be around 0.66. Okay, so this would be around 0.67. This would be around 0.58. Then 0.76 and 0.56. Okay, then this would be around 0.76, and this I would be getting around 0.56. So that means sample 1 would be good. Okay, that means sample 2 again this would be good, sample 3 again this would be good, and sample 4 would also be good, because all the values are greater than 0.5. That means all the labels belongs to good. Okay, all the label belongs to good. Okay, all the labels belongs to class good, right? So this is part A. Okay, this is part A. Now what is part B? If the sample class label is good with a probability of 0.28, what could be the value of independent variable x in the sample? So he is saying that probability is 0.82. Okay, he says the probability, the sigma z value is 0.82. Okay, so what is sigma z value? This is sigma z value, that is 0.82. So what could be the value of x? So 1 plus e to the power of minus m. Okay, what is m here? M here is 0.4. Okay, 0.4 x plus 0.2. So this we have to solve it. Okay, so how to solve this? Very simple. One upon 0.82. Okay, so e to the power of minus 1. So from here I can get x equals to 3.295. exactly, I can get x equals to 3.295. So this would be the answer. Okay, for part B, this would be the answer for part B. Okay, this would be the answer for part B. Okay, I'll wait for a minute, please write it. Okay, please complete it. I'll wait for a minute. I have certain more questions, we'll do that. Okay, so we have certain more questions, we'll do this. Okay, I'll wait for a minute, please complete it. Yeah, I hope now this is clear. Yes. Okay. So here, okay. So here in the next question, we have the logistic regression problem. Okay. In the next question, we have the logistic regression problem where infection probability, where infection probability, okay, where infection probability is given. Okay. uh, that is equals to 0.07 CRP plus 0.15 PCT minus 15. Okay, this is the decision boundary that is given. Okay, and he says if probability comes greater than 0.5, then assign bacterial infection. If probability is less than 0.5, then assign viral infection. Up now for part 1, at CRP 75 PCT 8, just tell me whether the person has bacterial infection or viral infection. And for part 2 at CRP 58 and PCT 66, tell me whether the person has bacterial infection or viral infection. Okay, yes, please try this. Please everyone try this. Okay, just try to do this. Okay, then we'll proceed towards the next concept. Okay, so just last question from my side on this concept, then we'll start with the next concept. Now, how to do this? Very simple. Okay, so we have sigma z as 1 upon 1 plus e to the power of minus 0.07 CRP, okay, plus 0.15 PCT, okay, minus 15. Okay, so this we have sigma z, this we have. Okay, now for part 1, okay, for part 1, so for part 1, yeah, so for part 1, yes, so sigma when CRP is 75 and PCT equals to 8, okay, PCT equals to 8, so this would be, okay, this would be given as 1 upon 1 plus e to the power of minus 0.07 into CRP, that is 75 plus 0.15 into 8 minus 15. Okay, so this you have to calculate. And for the second part, where CRP is 58, okay, CRP is 58 and PCT, that is 66, okay, PCT is 66, so I would be calculating this as 1 plus e to the power of minus, okay, minus 0.07 into 58 plus 0.15 into 66, okay, minus 15. तो what is sigma z in case 1? What is sigma z in case 1? तो sigma z in case 1, तो sigma z in case 1 would come about 0.9047, okay, and sigma z in case 2 would come around, yeah, sigma 2 would come around 0.2611, okay, so this would come around 0.2611, okay, 0.000194, okay, अच्छा अच्छा, हाँ 0.000194, ठीक है 0.0009, यस यस यस, ओके फाइन फाइन फाइन, 0.0009, ओके ओके, नो वरीज, यस यस यस, करेक्ट, यू आर करेक्ट. तो सिग्मा जेड वुड बी 0.0009. So the first one, yeah, correct, first one is less than 0.5, so that means first one is viral infection, okay, first one is viral infection, okay, and second one is greater than second one is also less than 0.5, second one is also less than 0.5, so that means second one is also viral infection, ओके, सेकेंड वन इज ऑल्सो वायरल इन्फेक्शन, ठीक है भाई, करेक्ट. तो दोनों ही केस में इस आदमी को वायरल इन्फेक्शन है, ठीक है, दोनों ही केस में इस आदमी को वायरल इन्फेक्शन है, करेक्ट. इन बोथ द केसेस ही हैज वायरल इन्फेक्शन, ओके, फॉर बोथ द केसेस ही हैज वायरल इन्फेक्शन, ओके. For both the cases he has viral infection, okay. चलिए, now I just want that you should do this as the homework, okay. So this question you should do as homework, right, this question you will be doing as homework, okay. चलिए, now after this let us start with one more important concept. That concept is classification matrix, okay. Now in case of classification, how to judge classification performance matrix, okay, classification performance matrix, okay. So what are the matrix to judge, yeah, what are the matrix to judge the classification problem, whether the accuracy is high or whether the prediction rate is good or not, okay, whether the prediction rate is good or not, right. How to judge that classification performance in case of these problems, okay. तो यहाँ पर एक बहुत common term जो आता है, that is confusion matrix, okay, a very important term, that is confusion matrix, that you have to understand and you should be capable enough to draw the confusion matrix, okay. You should understand and capable enough to draw the confusion matrix, okay. अच्छा, अब यहाँ पर let us see what confusion matrix is. It is used to describe the true positives, false positives. So you just write the definition of it. It is used to describe the true positives, okay, true positives, false positives, true negative and false negatives, okay, true negatives and false negatives, okay, true negatives and false negatives values based on the given data set and associated prediction output. Based on the given data and associated prediction output, okay, associated prediction output. So it is the performance matrix, okay. So confusion matrix I would also write, it is the performance matrix. Okay, what is this? It is a performance matrix. Okay, it is a performance matrix and it depends on training dataset labels only. Okay, it depends on training dataset labels only. It depends on training dataset labels. Okay, ये कभी भी टेस्टिंग डेटासेट पे नहीं बनाया जाता. इट इज ऑलवेज डिपेंडेंट ऑन द ट्रेनिंग डेटासेट. ओके, इट इज ऑलवेज डिपेंडेंट ऑन द ट्रेनिंग डेटासेट. ओके, एंड फॉर एग्जांपल फॉर बाइनरी क्लास, the shape of the confusion matrix is 2 cross 2. Okay, shape of confusion matrix for binary class, this is the shape of confusion matrix. Okay, for binary class क्या shape होगी? 2 cross 2. Okay, अगर क्लास में 3 classes are there. Okay, for multi class. Okay, तो for multi class क्या shape हो जाएगी? n cross n. Okay, for multi class जहां पर टोटल n क्लासेस हैं तो उसकी शेप क्या हो जाएगी? n क्रॉस n. ठीक है, फॉर मल्टी क्लास द शेप वुड बी n क्रॉस n. ठीक है, अब यहां पर समझेंगे. नाउ लेट अस अंडरस्टैंड what exactly the true positives are, what exactly true negatives are, what exactly false positives are and what exactly false negatives are. ठीक है, चलो अब मेरे साथ 5 मिनट अपने मुझे दे दो. आई विल मेक द थिंग्स क्रिस्टल क्लियर. ठीक है, अब जैसे मान लीजिए कि आई हैव अ मशीन. ठीक है, अब जैसे मान लीजिए कि आई हैव अ मशीन. ओके, एक ये मशीन है. ठीक है, जो कि एक्चुअली प्रेडिक्ट करती है, विच एक्चुअली प्रेडिक्ट्स. ओके, दिस सिस्टम और दिस मशीन इज अ prediction classifier. Okay, for example this is a machine or a classifier. For example this is a machine or a classifier. Ab now we have 2 scenarios. Okay, we have 2 scenarios before classification. Okay, before prediction. Okay, the scenario is before classification and the scenario is after classification. What is classification? That means prediction. आफ्टर क्लासिफिकेशन और प्रिडिक्शन. ठीक है, और एक सिनेरियो क्या है? बिफोर क्लासिफिकेशन कह लो या फिर प्रिडिक्शन कह लो. ठीक है, बिफोर क्लासिफिकेशन कह लो या फिर प्रिडिक्शन कह लो. तो गाइज जस्ट मेरे को 5 मिनट अपने देना. आई वुड मेक द कॉन्सेप्ट क्रिस्टल क्लियर. ओके, अब देखो, अब बिफोर क्लासिफिकेशन और प्रिडिक्शन मान लीजिए कि मान लीजिए दिस मशीन इज अ कोविड क्लासिफायर. ओके, दिस मशीन जो है दैट इज अ कोविड क्लासिफायर. ये बताता है कि बंदे को कोविड है कि नहीं है. इट टेल्स अस दैट वेदर अ पर्सन हैज कोविड और नॉट. ओके, इट टेल्स अस वेदर द पर्सन हैज कोविड और नॉट. अब बिफोर क्लासिफिकेशन, ओके, बिफोर प्रेडिक्शन, आई नो दैट देयर आर 10 persons, ओके, विच हैज कोविड. Okay, there are 10 persons which has COVID and we have 15 persons which doesn't have COVID. Okay, this information we have. So this is what? This is the actual data. Okay, this is the actual target, actual classes. Okay, this is the actual classes. Okay, that we know that before prediction the 10 persons actually has COVID and 15% doesn't have COVID. Okay, this is before prediction. Before prediction I know that 10 persons have COVID and 15% doesn't have COVID. Okay, अच्छा, अब after the classification from the COVID classifier. Okay, after the classification from the COVID classifier, this classifier predicts that the 15 persons, this classifier predicts that 20 persons have COVID. ओके, 20 पर्सन्स को कोविड है. ओके, एंड मतलब टोटल आई हैव हाउ मेनी वैल्यूज? टोटल 25 डेटा सेट इज देयर. ओके, 25 सैंपल्स आर देयर. ओके, टोटल 25 सैंपल्स आर देयर. तो 20 पर्सन्स हैव कोविड and 5% doesn't have COVID. Okay, this is what? This is the prediction. This is what? This is the prediction from the classifier. Okay, this is what? This is the prediction from the classifier. ठीक है, अब now based on this data, I would just define the first term, that is true positive. तो what is true positive? True positive is defined as जिसको actually में भी कोविड था और आफ्टर प्रिडिक्शन भी कोविड है, that is known as true positives. Okay, मतलब actually positive and predicted also positive, actually positive and predicted also positive, those are known as ट्रू पॉजिटिव्स. ओके, एक्चुअल में भी कोविड था और प्रिडिक्टेड भी कोविड है, तो दोज आर नोन एज ट्रू पॉजिटिव्स. ओके, तो अब जैसे मान लीजिए कोविड क्लास को मैं ले लेता हूं पॉजिटिव क्लास, दिस इज पॉजिटिव क्लास, एंड नॉन कोविड को ले लेता हूं, दिस इज नेगेटिव क्लास. सिमिलरली कोविड इज माय पॉजिटिव क्लास एंड नॉन कोविड इज माय नेगेटिव क्लास, राइट. तो जिसको एक्चुअली में कोविड था और प्रिडिक्टेड भी कोविड है, दैट इज नोन एज व्हाट, दैट इज नोन एज ट्रू पॉजिटिव. ठीक है, अब बात आती है ट्रू नेगेटिव की. अब बात आती है ट्रू नेगेटिव की. व्हाट इज ट्रू नेगेटिव? जिसको एक्चुअली में, मतलब द पर्सन हु डिडंट हैड कोविड, एक्चुअली ही वाज नेगेटिव एंड प्रेडिक्टेड आल्सो ही इज नेगेटिव. एक्चुअली आल्सो नेगेटिव and predicted also he is negative, that is known as what? That is known as true negative. Okay, actually also belongs to negative class and after prediction also it belongs to negative class, he is known as true negative. Okay, he is known as true negative. Now what is false positive? Now what is false positive? False positive is what? False positives actually belongs to negative class. Okay, but predicted positive, he is known as false positive. Actually belongs to a negative class but predicted positive, he is known as false positive. And what is false negative? What is false negative? Actually he belongs to positive class. Actually he belongs to positive class but predicted negative, he belongs to false negatives. So if I want to make this, if I want to make this in a matrix form, so how to make this? Very simple. So on the top I would write actual classes, on the top I would write actual classes, and on the left hand side I would write predicted classes. Okay, on the left hand side I would write predicted classes. So I would start from positive negative, here I would start from positive negative. So actual positive, predicted also positive, that is known as true positive. Okay, actual positive, predicted also positive, that is known as true positive. Okay, actual positive, predicted also positive, that is known as true positive. Okay, actual positive, predicted negative, so that is known as what? That is known as false negative. Actual positive, predicted negative, that is known as what? False negative. Actual negative, predicted positive, this is known as what? False positive. And actual negative, predicted also negative, this is known as what? True negative. Okay, this is known as what? True negative, right? This is known as what? True negative. Okay, this is known as true negative. So this you have to remember, that what is false positive and what is false negative. Okay, so this you have to remember, what is false positive and what is false negative. Okay, acha, and very important, if you just sum the true positives and false positive, so that is what? That is predicted positive. Okay, that is what? That is predicted positive. Now can you tell me? Yes, I need answer from your side, that what is the value of true positive plus false positive? I need answer from your side. What is the value of true positive and false positive according to this case? What is the value of true positive and false positive according to this case? So if you just see that this 20 is what? This 20 is what? These are the predicted positive. Very important concept. Very important concept. Again I say, this 20 is what? This 20 is the total predicted positive. That means if I want to write, I just ask from you that if I want to write what is this row, summation of this row, so summation of this row would be how much? This would be 20. I hope you are getting this. I hope you are getting this. So summation of this row would be what? This is 20, because predicted positive, भैया ये पहले का केस था. दिस वॉज द केस बिफोर द प्रिडिक्शन वेयर आई हैड 18 कोविड 15 नॉन कोविड. ओके, आफ्टर प्रिडिक्शन उसने बोला, क्लासिफायर ने बोला भैया 20 बंदों को कोविड है. He said 20 have COVID. So that means these are predicted class. This is predicted class. That means this is what? This is the 20. Okay, this is 20. Ab, what is the predicted negative class? Very simple. This 5 is predicted negative class. Okay, so this 5 is predicted negative class. So if I just sum, so I would get 5 here. Okay, this 5 is the predicted negative class. Okay, now again I would ask that what is the actual predicted, what is the actual positive? That is 10 here. Okay, this is the actual positive, that is 10 here. So if I want to mark this in the confusion matrix, so what is this? This would be 10. Okay, this is what? This is actual positive. Actual positive matlab before classification, how many persons had COVID? So before classification 10 persons had COVID. Okay, before classification 10 persons have COVID. Okay, and before classification how many person didn't had COVID? So actual negatives, this is what? This is actual negatives. Before classification how many person didn't had COVID? Total of 15 persons didn't had COVID. Okay, so a total of 15 persons didn't had COVID. Okay, so that means if I sum actual positive and actual negative, that is how much? That is 25. If I sum predicted positive and predicted negative, that is how much? That is again 25. That means number of samples won't change. Number of samples won't change. The prediction capability would be identified in this matrix. So this 2 cross 2 matrix, this 2 cross 2 matrix would give me the prediction capability. Okay, this 2 cross 2 matrix would give me the prediction capability. तो इसका मतलब क्या हो गया? इसका मतलब ये हो गया कि ये जो नंबर 10 plus 15 before classification, those samples would be equals to 20 plus 5. Okay, so this whole number won't change because samples won't change. No, only the prediction capability would be decided here. Okay, only the prediction capability would be decided here. So that means this is a 2 cross 2 matrix which actually gives us true positive, false positive, true negative and false negatives. Okay, I'll wait for a minute बच्चा. I want you should write it. Then उसके बाद हम करेंगे precision, recall, accuracy, F1 score. और भी कुछ बचा होगा तो वो भी कर लेंगे. अब पानी पी लूं मैं, जल्दी से लिख लो, फिर करते हैं भाई आगे. Okay, चलिए, now I would be defining certain important terms. The first term that you should know is precision. Okay, the first term that you should know is precision. Okay, the first term that you should know is precision. So it is defined as the ratio of true positive upon true positive plus false positive. Okay, it is the ratio of true positive upon true positive plus false positive. This you should know. Okay, तो इसका मतलब what does it means? Now what does it means? It means that the model which has predicted positive, okay, मॉडल ने जो पॉजिटिव प्रेडिक्ट किया उसमें से कितने एक्चुअली पॉजिटिव हैं. अगेन आई वुड से द मॉडल विच प्रेडिक्टेड पॉजिटिव. ओके, दिस इज जस्ट द सिग्निफिकेंस ऑफ इट. दैट इज जस्ट अ सिग्निफिकेंस ऑफ इट. द मॉडल दैट प्रेडिक्टेड पॉजिटिव, among that how many were actually positive is actually given by what? Precision. Is given by what? Precision. If at all you are not able to understand the significance, just don't worry. At least just understand this meaning. Okay, at least understand the meaning. Okay, the true positive upon true positive plus false positive. Yes, Uddhav, I hope this is clear, no, Uddhav? Okay, then next is recall. Okay, then next is no recall. Then next is recall. True positive. Recall is what? I'll just tell. Recall is what? Recall is true positive upon true positive plus false negatives. Okay, this is recall. Okay, this is recall, right? Recall is what? True positive upon true positive plus false negative. That is recall. Okay, then accuracy is, how accuracy is defined? Accuracy is defined as true positive plus true negative plus true negative upon true positive plus false positive plus true negative plus false negative. This is how accuracy is defined. Okay, this is how accuracy is defined. Then next is F1 score. Okay, next is F1 score. That is a harmonic mean of what? Harmonic mean of precision and recall. Okay, this is a harmonic mean of precision and recall. Okay, this is the harmonic mean of precision and recall. Okay, then we have sensitivity. Very important. Sensitivity is same as recall. Okay, so sensitivity is same as recall. Okay, sensitivity is same as recall, right? Next is sensitivity. Okay, this is sensitivity. This is same as recall. Okay, then we have specificity. Okay, then we have specificity. Specificity is defined as true negative upon true negative plus false positive. True negative upon true negative plus false positive. This is how specificity is defined. Okay, this is how specificity is defined. So these are 6 important parameters, okay, to classify. These are 6 important parameters to classify any classification model. Okay, these are 6 important parameters to classify any classification model. Okay, these are 6 important parameters to classify any classification model. And we also have one error rate, right? So I would just write error rate also. Very simple, nothing much. Error rate, that is just 1 minus accuracy. Okay, 1 minus accuracy, that is nothing. This is just 1 minus accuracy, right? So you can just write all these formulas. Okay, you can just write all these formulas. Okay, अब now which one to calculate in which data set, this we would look. Okay, I'll just give you a very simple example, you would get it very easily. Okay, कि which one to calculate where. Okay, which one to calculate where. So please write it first, I'll wait for a minute, then I'll just give you a very interesting example, which one to calculate where. Okay. Yes, specificity is for negative classes, definitely. Yes, अब now I'll just tell you कि where to calculate what. ठीक है, अच्छा, अब now let us I'll just take your 5 minutes for a business understanding perspective, right? I mean the position such as business analyst, no? I hope you have heard that position, no? Business analyst, very important. So basically what is expected from them, no? Now let us see. देखो, अब क्या होगा? जैसे मान लीजिए I want to make a COVID classifier, ठीक है? अब मान लीजिए मुझे क्या करना है? I want to make a COVID classifier. Okay. अब here I just saw that the 10 persons before the classification I know 10 had COVID and 15 doesn't have COVID. Okay, after classification 20 were predicted positive and 5 were predicted negative. अच्छा, अब let us, you just consider this case, मान लो, okay, just let us consider this case. For example, the persons who are predicted who actually have COVID, the persons who actually have COVID, when they are predicted COVID, that is true. Okay, that is fine, that I want, but that is how our algorithm should work. Okay, but for example, the person who actually have COVID and they are predicted that the person doesn't have COVID. Okay, तब क्या होगा? I hope you are getting this. जिन बंदों को कोविड था, क्लासीफायर ने बोल दिया भैया इन बंदों को कोविड नहीं है, तो होगा क्या? What would happen? भाई उनको क्या होगा? They would roam around and they would spread COVID to everyone. I hope you are getting this. I hope you are getting the seriousness of this issue. The person who had COVID and predicted negative, मतलब for example I have COVID and I am predicted negative. मेरे को क्लासीफायर ने क्या बताया कि I am predicted negative. अब मैं क्या करूँगा? What I would do? I would just roam around everywhere. I would just meet to everyone and I would make every other person COVID. Don't you think that this is a blunder? Don't you think that this is a blunder? So that means which is more important here? Is false positive more important here or false negative more important here according to you? भाई क्या ज्यादा जरूरी है? Whether false positive is more important or false negative? अब I had COVID and I said and I am predicted that I doesn't have COVID. मेरे को कोविड था और मुझे प्रेडिक्ट किया आई डजंट हैव कोविड. दैट मींस फॉल्स नेगेटिव इज मोर इंपॉर्टेंट हियर. आई होप यू आर गेटिंग दिस. भैया फॉल्स नेगेटिव तो ब्लंडर कर देगा. आप समझ रहे हो? मैं कोविड था, क्लासीफायर ने बताया मुझे कोविड नहीं है, मैं क्या करूंगा? भाई मैं तो घूम रहा हूं मजे से, आई एम जस्ट रोमिंग अराउंड मीटिंग एवरी पर्सन. होगा क्या उसमें? होगा क्या? एवरी पर्सन वुड गेट कोविड. तो इन दिस scenario, what is more important? False negative is more important. That means what I shall calculate? Either I should go towards calculating this precision or I should go towards calculating the recall. I need answer from your side. What I should calculate? Shall I calculate precision or shall I calculate recall? So in this case I would be calculating recall. Definitely in this case what I would do? I would be calculating recall. भैया precision निकाल भी दूंगा. देखो precision अगर निकाल भी दिया तो what exactly precision is? Precision is that the person who doesn't have COVID, he would be quarantined. यही तो होगा ज्यादा से ज्यादा. और क्या होगा? मान लो false positive क्या हुआ? What are false positive? I didn't had COVID. What are false positive? What is false positive? I didn't had COVID. The machine predicted that I had COVID. I didn't had COVID. Machine predicted that I had COVID. मतलब I am a false positive. अब ज्यादा से ज्यादा क्या करेंगे? मेरे को ज्यादा से ज्यादा क्वारंटाइन कर देंगे 14 दिन. I would be quarantined 14 days. अब ठीक है यार, मतलब that is not that much dangerous, no? That is not that much dangerous. Okay, but if I am having COVID or the classifier says I don't have COVID, भाई मैं तो सबके L लगा दूंगा. I hope आप समझ रहे हैं ये चीज. तो there there actually recall is important. Here actually recall is important. So that is the business perspective, what a business analyst is expected to do. I hope you are getting now. I hope things are clear to you. Okay, this is the business perspective that a person, that a business analyst, data analyst is expected to cover all these things, है ना? So that is what this whole analysis works on. This is the analysis, this is the back end of the analysis that one data analyst, data engineer or data scientist should know. Okay, so that is why I would be calculating recall. Okay. Okay, so if things are clear, let us do one question. Okay, if things are clear, then let us do one question. Okay, start with this question. Everyone, I want everyone to start with this question. Okay. Now what this question says, a model is trained with 20 samples and also evaluated with 20 samples. Very good. Model predicts 16 samples as positive samples, but only 8 samples are true positive in that prediction. Okay, so what he says there are total of 20 samples. Okay, what he says there are a total of 20 samples, right? Model predicts 16 samples. Model predicts 16 samples as positive samples. Okay, so this is what this is predicted positive. Okay, so if you just draw the confusion matrix, if you just draw the confusion matrix, this is actual class, this is predicted class, this is positive, this is negative. Okay, this is positive, this is negative, right? Now what the sample says, sample says there are 20 samples, model predicts 16 samples as positive samples, so this summation is 16. I hope you are getting this. This summation is 16, and out of these 16 samples, only 8 samples are true positive in that prediction. What is precision? Precision is what? True positive upon true positive plus false positive. That means 8 upon, now this is false positive. Okay, this is false positive. So 8 upon 8 plus 8, that is 0.5. Okay, that is 0.5. Okay, I hope things are getting clear to you. Yes, so I think I shall see certain likes and certain comments here. Okay, if things are clear, I think I can expect certain likes and certain comments. Please, everyone. Okay, chalo. Next question. Everyone, quickly. Next question. Quickly, next question. I think you should answer. Everyone should answer this. So what this question says? It is trained with 30 samples. "24 samples actually positive." Okay, so I'll just draw the confusion matrix. The model is trained with 30 samples, right? 24 samples are actually positive. Machine is evaluated with the training data set. In that, model predicts 20 positive samples. And in that, yeah, sorry, this is not 24, this would be 24. And it predicts 20. It predicts 20 positive samples, and in that 16 are true positive. Okay, 16 are true positive. So that means what are false positive? 4 are false positive. How many false negatives? 8 are false negatives. Okay, and since 30 samples are there, 24 actually positive, so 6 are actually negative. That means two samples are false negatives. Okay, so it is a 2 cross 2 matrix. Now what exactly we want? We want precision. Precision is 16 upon 16 plus 4, 16 upon 20. Okay, correct, 0.8. 16 upon 20. Okay, 0.8. This question you would do as homework. Okay, this question you would do as homework. This question again you would do as homework. Okay, please note it. I'll just upload the file. Please help among yourself how to get the file. I'll upload it in the resource section itself. Here itself we have that link, PDF link. You can directly get it from here. Okay, this question you would do as homework. Let us calculate this question. Okay, let us solve this question. Please, everyone. We have to calculate precision and recall. Okay, we have to calculate precision and recall. कैसे करेंगे? देखो, here this y and y hat is given. मतलब this question focuses on what? Focuses on the basic principle. Okay, this question focuses on basic principle, basic concept. Okay, basic understanding of your concept. So he says model is evaluated with the positive prediction. What is precision and recall? Okay, what is precision and recall? actual classes and here I have predicted classes. ठीक है, चलो अब what are true positives? True positives are what? Actually positive and predicted also positive. So this is a true positive, this is a true positive, this is a true positive, and this is true positive. So how many true positives are there? Total of 4 true positives are there. Okay, how many true positives are there? A total of 4 true positives are there. Up now true negatives. Let us calculate true negatives. How many true negatives? 5th one is true negative, 7th one is true negative. Okay, so that means 2 true negatives are there. Then false positive. False positive is what? Actual negative. Actual negative, predicted positive. So only second one is there. Actual negative, predicted positive. Actual negative, predicted positive. So only one false positive is there. Actual negative, predicted positive. And how many false negatives? How many false negatives? No, actual negative, predicted positive. Yes, we have 2. Actual negative, predicted positive. Okay, we have 2 false positives. Okay, we have 2 false positives. Actual negative, predicted positive. We have 2 false positives and 0 false negatives. Okay, so 0 false negatives. Actual positive, predicted negative. Okay, actual positive, predicted negative. So we have 0 false negatives, right? Now what I want is, I want precision. What I want is, I want precision. What is precision? Precision is true positives. 4 upon 4 plus 2. Okay, 4 upon 6. What is precision? Precision is 4 upon 6. Okay, yes. What is recall? Recall is true positive upon true positive plus false negatives. So what is true positive? 4 upon 4 plus 0. So that means recall is 1. Okay, recall is 1. Okay, and what is the accuracy of the model? What is the accuracy of the model? Accuracy is true positive plus false positive upon true positive plus false positive, true positive plus true negative. Okay, false positive, yeah, true negative plus false negative. Okay, so what are true positive and true negatives? 4 plus 2 upon 4 plus 2 plus 2 plus 0. So that means 6 upon 4 or 4 8. 6 upon 8. Okay. Okay, so this is how we have to solve this. So guys, I am giving you certain questions as homework. This is a homework for you. Okay, this you have to do as homework. Okay, I am writing certain points. This you have to do as homework. Okay, this is homework. Then this also you have to do as homework. Okay, you know the concepts. I have number of questions. You would be doing this as homework. This again you would be doing as homework. Okay, yes. Then this we would be covering in the next class. This is a multi-class problem. Okay, so just don't do this. This is a multi-class problem where we have 3 classes. Okay, we have urgent, normal, spam. Okay, so apart from these questions, every other question you can solve. Okay, apart from these questions, every other question you can solve. Okay, so guys, I would be summing up here, and one concept is there for tomorrow. I would be just discussing this concept tomorrow with you. Okay, so all these questions are given as homework. So please, I want everyone of you to solve these questions. Okay guys, chaliye, so I'll just end here and let us meet tomorrow same time. Okay, let us meet tomorrow same time. tomorrow we would be starting, tomorrow we would be starting with either decision tree or support vector machine. I'll just let you know. Okay, tomorrow either decision tree or support vector machine. Yes, now I would just see in the notes. Yes, I would just a minute. No, Newsbuster, I'll just see. Okay, this is the thing, no, that we have written. Okay. SPX1Y, SSX2, SPX1X2, SPX2Y upon SSX1, SSX2, SPX1X2 whole square. This is correct. SPX2Y, SSX1, SPX1X2, SPX1Y, SSX1, SSX2 minus SPX1X2 whole square. Guy, Newsbuster, I think this is correct. I think this is correct from my side. M2 is SPSS, then acha, this is SPSP. Okay, yeah, this would be SPSP. ठीक है, correct, yes, correct. M2 would be SPSP. ठीक है, this same would come here. Yeah, correct, you are correct. Okay, I'll just correct it. This is SP into SP by mistake. Yeah, mistakenly I've written this. Okay, correct, you are correct. So this would be SP into SP. No worries, I'll correct it. I'll correct it in the final file. Then I'll upload it. Okay, done. ठीक है guys, thank you so much. Okay, let us meet tomorrow. Thank you so much.